Hello, surveying class. Today's topic is bearing and azimuth, reference meridian, magnetic declination and its variation. We will discuss today in following point. So, what is objective of this point? Point bearing and azimuth in surveying angle. Bearing and azimuth in surveying angle and length are basic measurement in surveying. Angle in surveying are classified as either horizontal or vertical based on the plane in which they are measured. So, horizontal angle are the elementary observation required for determining bearing and azimuth. So, determining the position of point and orientation of line often depends on the observation of angle and direction. In surveying, direction are recorded using bearing and azimuth. What means I think you should understand by this diagram. Suppose, my dear, this is so this is north, south, east and west. So what is north, my dear boy? What is east? What is west? What is south? What is south? Anybody can tell me? These are direction. These are directions. These are governed to us. What is our direction to move? You will surprise if you have not knowledge of the direction. You cannot move. Where you will go? Direction is a very important thing. It has given information to our exact location. So, in surveying, direction are recorded using bearing and azimuth. Now, what is bearing of a line? What is the bearing of a line? So, bearing of a line is the angle measurement. Bearing of a line is the angle measurement. And bearing of a line, the angle measured from either the north or south end or reference meridian. The angle is observed from north or south toward the east or west to give a reading less than 90%, 90 degrees. So bearing is represented by the letter number This is north or south preceding the angle, and the ERW succeeding it demonstrates its appropriate quadrant. Understand? The angle is observed from north or south toward east or west. To give a reading less than 90 degrees, bearing is expected by the letter north N or S preceding angle, the east, sorry, E or west. So succeeding it demonstrates the appropriate quadrant. And now we will discuss, dear boy, what is the bearing. A, proplex, a properly expressed bearing contains quadrant letters and an angular value. Since bearing is with the reference to north-south line angle, they are measured clockwise. What is clockwise? The direction to move the clock is clockwise. So we are discussing the clockwise in the first and second, now NE and SW quadrant, and it measure anti-clockwise in the second and fourth quadrant, NW and SE. This is also known as quadrant bearing. Okay, as a quadrant bearing. I think that this is indicating north, and this is the so this is north, this is south, east, and west. So my dear boy, this is first quadrant, this is second, this is third, this is fourth. So what is the name of this quadrant? This quadrant name is the northeast. Any. What is the quadrant name? This is the SE. And what is this? This is SW. And what is this? This is NW. Then you are seeing we have indicating always connected with north or south. Now, when bearing are measured with reference to two meridians, it is called a true bearing. If the bearing is from magnetic meridian, it is magnetic bearing, and when from a grid, it is grid bearing. So, the example of bearing and calculation is given. This is example. My dear boy, in this diagram, a person is stand on the line of north. This is This is the line of north. And this is the sun line. So this is north. This is what is this? This is direction. And what is this? This is azimuth. And what is this? This is elevation. Yani if we are measuring in the case of horizontal direction, so our direction is north, south, east, west, or middle line it is azimuth, but it is top, then it is called elevation. Okay, clear? What is azimuth? So many students have been asked what is difference between north bearing and azimuth. So in this lecture, I will very clear what is your bearing and what is azimuth. Dear boy, the azimuth is the angle between north measured clockwise around the observer's horizon and celestial body. So sun, moon, it determine the direction of the celestial body. For example, a celestial body to north has azimuth of 0 degree. On the due east 90 degree, one due south 180 degree, and one due west 270 degree. In this you have a diagram, you can understand better. This is north, this is south, and this is east, and this is west. This is north, this is south, this is east and west. So dear boy, from here to here, this is 90 degree, and here to here, this is also 90 plus 180 degree, and here yani you are measuring entire all the bearing towards north, because that is 0, and you have start from 0. So here to it have 270 degree and entire all 360 degree. Okay, and 360 or 0 are same. Okay, my dear boy. Now up view representing the azimuth 0 degree, 90 degree, 180 degree, and 270 degree. On the planar, you will find the azimuth and elevation of the sun, moon for the selected date and time on one of the top panels. The azimuth is also representative on the map with the azimuth line and the elevation on the time bar. To help you better understand how the azimuth is represented on photofields. I have drawn north and azimuth along the sun at two different moments. The following screenshot. The first one is telling you on the February 11th, 2014 at 10:17, and the sun was azimuth 136.5 degree, and the second one that February 11th, 2014 at the 3:1 p.m. sun was at azimuth 214.6 degree. This is the situation. One time we have taken the morning and one time taken the evening. Now, my dear boy, what is the elevation? The elevation is the vertical angular distance between a celestial body. So, celestial body, sun, moon, and the behavior local horizon are also called me observer local plane. Now, for us, the elevation of the sun is an angle between the direction of the geometric center of sun, apparent disk, and the observer local horizon. We will say that the sun moon is at between of 12 degrees when it is the geometric center is situated at 12 degrees above the observer local horizon or local plane. The following two pictures show the elevation of the sun to different position on the observer. See this? This is, my dear boy, uh, elevation, and this is observer plan. So, why are azimuth and elevation so important for us? The photo pillars, the answer is simple, because we will need to calculate and set them to take advantage the fine precision of the planner and to plan our ideal sun and moon shot in just a second. So azimuth and elevation are the two coordinates that define the position of the celestial body, sun, moon in the sky, as viewed from a particular location at a particular time. Let's say that you wish the sun or the moon to be an determinate position in the sky because you love the composition. That position in the sky is defined by the azimuth and elevation. Now, variations of magnetic declination. Now, what is the variation? So, daily variation means, my dear boy, also known as diurnal variation. Extreme position of the needle usually occurs early in the morning, and extreme western position occurs just about after noon time. So usually neglected when observing magnetic direction. Now see this picture and see carefully. This is true north and this is magnetic north. And this is magnetic north and this is true north. The morning position is this and afternoon position is so also known as yearly variation. Amount only less than 1 minute of arc and thus considered negligible. Now slow, gradual but unexplainable, the meridian swing in one direction for about 150 years and come to a stop and swing back in the opposite direction. It is important and not negligible because of its magnitude. No mean of formula to predict this variation. No mean of formula to predict this variation. Nature and behavior can only be described from past observation. This is a table which I have presented for you observation. Now occurs unpredicted. So during magnetic storm and disturbances associated with sunspot and auroral display occurrence. Now isogonic chart. Now we will discuss isogonic chart. You have seen this chart also in a contour line. This is called isogonic chart. This is isogonic map. So tell you how far from true, not a compass will point anywhere along any isogonic line. You can see this is isogonic line. Now, historical magnetic declination. So, find magnetic declination with the Google map. You can see by this. So, use of the compass. Dear boy, we will discuss about the what is the compass. Actually, compass is an instrument. On that, we can find what is the direction of Earth. But how? How can do? How compass the work? Anybody can tell me how compass the work? Actually, my dear boy, compass has work due to Earth, North Pole and South Pole. Due to Earth, North Pole and South Pole. So entire magnet, the top of the magnet needle has attract him at the North Pole. And naturally, second will be south. This is the compass. Now this is the local attraction. What is the local attraction? We will discuss about that, dear boy. If you are working on the compass, so if he is free from any effect of iron, then she will be moved directly to the north direction. But if the north direction, say more than effect iron, you have kept another place, so it will be confused. So he will be confused, and his movement will be governed to local iron who has kept to you, and that is called local attraction. Now, local attraction, in the definition, what is the local attraction? The deflection of a magnetic needle of compass from its true position. So due to the presence of magnetic influencing material, may be constant or may vary depending upon the surrounding magnetic influence. So the needle away, draw the needle away from the magnetic meridian. Now local attraction present when two object direction differ. Two observed direction differ. Now type of compass shall be. First, open compass traverse and close compass traverse. Up, this is the question. If you are doing open compass traverse, open means if a point is here and a point is here. So if you are running here, from here you have taken again here, here, here. This is open compass traverse. And closed compass traverse here, here. This is closed compass traverse. Okay. So are a series of lines connected to each other with known bearing and measurement. The line tangent cannot back to the original point and form the polytime. What is disadvantage? No arithmetic check available and therefore need an extra care on the measuring the bearing and its line, and need to measure the line twice and take the mean at its length to make it more accurate. Similar to an open compass traverse, but the series loops back to original point are huge, extensive in construction survey, the property and topographic survey due to its checking availability. Now, what is the advantage? Availability to check the angular measurement, sum of integer angle, so n minus 2, 180 degree, where n is equal to number of side. Now adjusting open compass traverse. Adjusting. So first step, make a sketch of the gathered data. And second step, determine which among the traverse line are free from local attraction. And third step, performing adjustment by starting from the best line or the unaffected line. Now adjustment of the closed compass traverse. Just you have seen what is the closed compass traverse. So plot or tabulate. So computing and adjusting the interior angle, selecting the best time, and adjusting the observed bearing of the successive line. Now the following forward and back bearing there of traversing with a compass. So this is the forward bearing and this is the back. What hoga? This is the point. If you calculate and if you will find out that is the forward bearing, so next will become backward. So calculate the interior angle and correct them for observational figure, assuming the observed bearing of the line. So PQ to be correct, adjust the remaining sides. This is close bearing. See this is the close bearing. But due to local attraction, the joint of arm is not possible. Solve for the interior angle. Now, this is the solving. Adjust interior angle. So now this is the calculation. And if you will discuss, if local attraction exit at the station, both backward and forward bearing are equally affected. Not one. Thus, interior angle computed from the forward and backward bearing are independent of local attraction. Now precision in compass work. So success of error in compass work we will discuss. No bent needle, bent power, status needle, plane offside, not vertical, electrically charged compass box, local attraction, magnetic variation, and error in the regrets. All observed bearing will have a constant error. Either end of the needle will read higher or BWER power than the correct value, etc. So a variable systematic error and magnetic compass, the magnetic to be error will be depend upon direction with the site of made. Now sluggish needle move unusually slow in the seeking magnetic north. It will be probably come to rest a little of the magnetic meridian. Most common cause weakening of the magnetic at the needle. So plane of the side, not vertical. These are when observing the direction of the time, the line of sight may be stiffly inclined the slight करना bus. An electrically charged compass by happiness when the glass over bucks in the surface. And local attraction, the correct pointing of the magnetic needle towards magnetic earth is the kindly. In this picture, you can see this. This is true north and this is meridian. So it's an error in the reading needle. The most accidental error in compass work is due to the inability of the observer to determine exactly the point on the graduated circle where the needle come to rest. So mistake in compass work. Mistake in the compass work. So reading the wrong end of the magnetic needle. So following the observe the reverse bearing of the azimuth of the line in the traverse. So misreading the quadrant letter when taking a bearing near the cardinal point of the compass. So bearing, correct the change when using the reserve bearing of a line. So setting of the magnetic deflection on the wrong side of the north and failing to adjust the observed traverse angle prior to calculating the bearing or azimuth or traverse line. Mixing of the interchanging the recurring of the azimuth from the north and south magnetic and true bearing clockwise and counterclock angle are forward and back. Selecting a line for referencing arbitrary direction which may be difficult to locate clutter. Now we will read direction and bearing. We'll read direction and bearing. What is difference between direction and bearing? Bearing may be anything, but direction cannot change. The direction and bearing. So just wait. Where is direction bearing? And so it is the direction of bearing. Now, yes. So now the direction of bearing. So there is the 8 major direction that we direction commonly used. The first 4 are called the cardinal direction. They called the cardinal direction. There are 8 major directions. So which are 8? Who are 8? Actually, this is 1 and 2, 3 and 4, 5 and 6, and 7 and 8. This is 8 direction. Okay. So there are 8 major directions that we commonly use. The first hour is called cardinal direction. Now, sometime another 4 directions are added. So there are directions like south, east, and north. Now, occasionally 16 directions are used. Example, WSW is equal to WS west, south, west, west, southwest. Now direction and bearing. So with more than 16 direction thing get quite confusing. So we are huge number called bearing. Now direction and bearing. So there are 360-degree of bearing. If you use decimal, there are even more. In fact, we commonly use only 360 through. So all of these bearing and direction appear. One magnet compass, which are used to figure out direction. So this is the bearing compass. A simple protractor can be used to calculate bearing on a diagram of map. So this is the line, this is the bearing. अब इसमें you will see this. This is the OA. This is the line. Bearing is and 60 degree and 60 degree east. Okay. It means which are the made between part that is called east or west. Like that, 0B, OB, O and B. This is the 32 degree. So what you will tell? S 32 east. It is from 32 is balanced from the S. Now Oshi. So S39W and OD and 45 degree west. So this is the line and bearing. And now what is azimuth in surveying? What is the azimuth in surveying? The azimuth are defined as a horizontal angle that are measured from the reference meridian in the clockwise direction. Azimuths are also called a whole circle bearing system. So azimuths are used in compass surveying and plane surveying. So what is azimuth surveying? Where it is generally measured from the north, but azimuths are measured from the south by astronomers and the military. Of now azimuth and bearing. Difference between azimuth and bearing in surveying. The value of varies from 0 to 360 degrees. Azimuth. In azimuth, you can calculate 0 to 360 degrees. But the value varies from 0 to 90 degrees. Bearing. Now represented by a numerical value and represented by two letters and the numerical value. Azimuth, the angle are measured clockwise only. Bearing, the angle are measured both clockwise and anti-clockwise. How? This is the from here to from here to from here to here. Now see this in this. You can take at azimuth. What is the? This is the angle. So this is 270 degree. But in this bearing, this bearing can be say, this bearing can be say, and this bearing can be say. So this is the difference. Clear? So dear boy, measures taken either from the north to south, and the angle can be measured either from the north or south for a single survey. Now This is the quadrant and bearing to azimuth conversion. What is the north is bearing equal to azimuth. What south is bearing equal to 180 degree minus azimuth. And southwest bearing equal to azimuth minus 180 degree. And northwest bearing equal to 360 degree minus azimuth. You can see this picture. This is azimuth and this is bearing. So what is the azimuth of a line? The azimuth of a line is defined in a horizontal angle measured clockwise from the base direction to given line, and they are usually measured from the both and vary from 0 to 360, and so they are not required later to categorize their quadrant. They will also add whole direction bearing. Also at whole direction. In the case of plane surveying, these azimuths are normally observed from the both, but astronomers, military have south direction. National Academic Survey have used south as reference direction to the North American datum NAD of 1927 had north as the reference direction for NAD 1983 figure 2 table 2. So the example and calculation of the azimuth here north direction taken as reference meridian. So dear boy, you have studied this all azimuth, meridian and others. So about this, I want to ask some MCQ from you. So I want to ask question, which are the following caused by the careless handling? Answer is the B, gross error. And a system will be error free if we remove the systematic error. It is correct, they are wrong. Answer B, this is wrong, false. And next, a series of closely spaced contour line approaches. What is answer? Answer is a slip slope. And now a negative declination knows the magnetic meridian to the, what is correct answer? Answer is B, western side of the true meridian. Now a telescope is said to inverted. If yes, what is correct answer? Correct answer is A. Vertical circle is to its right and the bubble of the telescope is down. An angle of 45 with the Gyan line may be set out with, give me answer. Answer is C. French cross stop. Now, a level line is a horizontal line or parallel line. What is the correct answer? Correct answer is the B. Line parallel. How? If, my dear boy, if you are doing the line, this is the your machine, this is the level line. So what is the horizontal parallel? So it is going the parallel the mean spherical surface of the earth. Understand? Now a gate kept fitted with what is correct answer? Answer is D, prismatic compass. And along 0, 0 slope, the correction to apply to each 30 meter. So what is the correct answer? Answer is A, 30 seconds. So thank you for taking interest in my class. And next chapter you will read in tomorrow. So again, thanks for joining the class.